So, first of all, I'd like to thank the organizers for giving me the opportunity to speak today. Thank you so much. Today, I'll be exploring the various types of advisory features available and the benefits they can offer. I'll focus on PG Plan Advisor that I have developed, and I'll include a demo to show you how it works. As experts in your field, I'm sure you are often asked for advice, whether you want it or not. My friendly advice today is to please bear with me until the end. But first, let me introduce myself briefly. My name is Tatsuro Yamada. I work for NTT Open Source Software Center in Japan as a database technical support team leader. I'm also a senior researcher involved in community development for Postgres. I have developed several Postgres features in the past. These include progress reporting features and PSQ meta command. My focus has primarily been on developing features that are useful for DBA. Lately, I've been interested in improving the usability of extended stats. In terms of Postgres extensions, I have contributed as a committer or author to several projects. Now let's move on. Today we'll cover three main points. One, overview of advisory features. I will introduce a list of various advisory features available worldwide that I am aware of. Two, PG Plan Advisor. I will explain its mechanism, effects, and new feature. Three, feedback to Postgres development. I will share thoughts and insights gained from developing new feature for PG Plan Advisor. Fourth, summary. I will wrap up the main points of the talk. Lastly, we will have a Q&A session. Please submit your questions through this QR code. During the Q&A session, I will pick a few questions to answer. If a question requires a more detailed response, I will follow up later if contact details are provided. It's challenging to answer questions in real time during a talk, so please hold your question until the end. The next slide will be an overview of the advisory feature. The dog is my pet. His name, Ku. What are advisory features? They are features that offer advice and suggestion to users. These features are widely available in both commercial and open source DBMS, helping many different kinds of users. If you are new to using database, advisory feature can compensate for lack of knowledge or experience, guiding you through complex tasks. On the other hand, if you are a database expert, these features can help you by comparing their suggestions with your ideas. This might enhance your strategies or even lead to new insights. As you can see, advisory feature holds substantial value for a wide range of users. In the next slide, I will take a look at the different types of advisory features that exist in the world today. Advisory features can be broadly categorized into four types. One, configuration parameters. This involves suggestions related to settings in the PostgreSQL file, such as recommendations for the shared buffer value. Two, indexes. Many of you might be familiar with this one. It suggests indexes that should be created. This feature has been implemented in many DBMS recently. Three, partitioning. Strictly speaking, this isn't exactly an advisor feature, but there is a tool available that allows you to virtually test partitioning configuration. For execution plans, this suggests more efficient execution plan than those provided by the planner. Please note that there are just categories I am aware of. There may be other useful advisory features out there. If you know of any, please feel free to inform me later. In the following slides, I will explore the tools available for these categories and discuss how they can be useful in different situations. The first one is about parameters. Choosing the right parameters for database setup can be challenging. In Postgres 16, there are about 400 configurable parameters. With so many options, determining the appropriate setting can be daunting. The suitable values for these parameters depend on server specifications and workload, making the configuration task is difficult without sufficient knowledge and experience. In such case, having a tool that suggests parameters can be invaluable to users. This list includes both paid and free tools. Let's take a look at PGConf and OttaTune as an example. PGConf suggests Postgres parameters based on the expected workload type, number of sessions, server memory, and CPU count. As an established tool, many of you might already be familiar with it. OttaTune is a relatively new tool. Unlike PGConf, OttaTune analyzes your actual workload to recommend settings. Here are some screenshots of these tools. The next slide will discuss the index advisor. After setting up the database, tables, and queries, the next step is creating indexes. The challenge here is determining which columns in the tables should have indexes. This is where an index advisor can be beneficial. This list shows those available as Postgres extensions. They are PGConf.stats and HyperPG. PGConf.stats is one of the well-known index advisors available in Postgres. It collects conditions from where and join clauses in executed queries. Then uses this information to suggest indexes. Another tool widely used across many databases, including those hosted by cloud vendors, is HyperPG. This extension allows you to create and test hypothetical indexes. It means virtual indexes. The advantage of hypothetical indexes is that they do not affect the actual data. Therefore, HyperPG can be considered a test bed for evaluating the effectiveness of indexes, and it has also been used to develop index advising capabilities. In the next slide, I'll show you the effectiveness of index suggestion made by PGConf.stats. The test used dbt3 query. The scale factor, meaning the amount of data, was 1 gigabyte. I will show you about the results of query 17. This is the result of my test. The query execution time was initially about 2 hours. But after creating the suggested index, it drops to just a few seconds. The performance improvement was 3,500 times. So it's particularly useful if you lack the knowledge or experience, or if you want to check for any missing indices. Additionally, this tool provides global index suggestions by considering columns across multiple queries. This helps prevent what we might call an index shotgun. Next, I will introduce advisory tools related to partitioning. If a table has an unexpectedly large number of records, you may need to consider partitioning. In such case, you will need to evaluate type of partitioning and partition keys. HyperPG, previously mentioned for hypothetical indexes, was also used for virtually testing partitioning strategies. This feature enabled users to experiment with the types of partitioning and partition keys without having to rebuild tables or reinsert data. But unfortunately, this hypothetical partitioning feature only worked with Postgres 10 and 11 and is no longer available. The reason why is because the partitioning-related API were changed in Postgres 12, which rendered the feature inoperative. As a developer of extensions myself, I understand the necessity of API change to advance Postgres development. However, I think it is a good idea to ensure backward compatibility as much as possible. For those interested in this hypothetical partitioning functionality, please refer to the material for PGConf Asia 2018. Next, I will talk about advisors for execution plans. Execution plan advisor tools are invaluable when query execution times exceed expectations, like during performance testing or with slow queries in production. I think DBA sometimes reads execution plans when looking for a reason why a query is slow. If the execution plan is long and complex, it will take time to discover the problem. There are tools available for such situations. I will show you the list on the next page. This is a list of tools to help you improve your execution plan. It's crucial to ensure that these tools are used under the premise that there is inefficiencies truly due to the execution plan. Let's take a look at examples such as AQO and PG Plan Advisor. Well known among these advisors are AQO and PG Plan Advisor. If you are familiar with any of these, please raise your hand. Please raise your hands. Oh, thank you. Thank you. So, as many of you may agree, irrespective of DBMS, complex queries involving many filters, joins, and aggregations can lead to inefficient execution plans. This inefficiency often arises from inappropriate plan node choice due to inaccurate cost estimations. These tools automatically correct errors in estimated rows and provide a mechanism for accurate cost calculation. It leads to select more efficient execution plan, thus reducing query execution time. I am sure some of you are interested in understanding how the tool works. From here, I will focus on PG Plan Advisor, for which I am the author, and explain its mechanisms, features, and effects. As you might know, there is a talk on AQO at 11:30 today, so please attend that for more information. Now let's take a closer look at PGPlan Advisor. My dog also seems to be interested in it. PGPlan Advisors offers the following 4 key features. 1. Displaying execution plan characteristic. 2. Automatic execution plan tuning. 3. Automatic hint clause generation. 4. Extended stats suggestion. I will explain each of these features in the following slides. The first feature is the ability to describe the characteristic of an execution plan. This is integrated into the output of the explain command. Let's look at an example to make it easier to understand. When you run an explain command, you get a result like this. The key area to focus on is labeled describe. This is information added by PGPlan Advisor to illustrate the characteristics of the plan. It includes details like query ID, plan ID, as well as the number of joins, scans, error information, and hints. Why is this information useful? Because it helps DBA to quickly grasp the characteristics of a plan. For instance, if a query is wrong and the execution plan spans 1,000 rows or more, reading and understanding the entire plan can be a daunting task. The feature allows you to quickly capture essential information. Currently, it displays information about joins and scan only. But I'm considering adding details about aggregates and other aspects in the future. Let's move on to the next feature. The second feature is automatic tuning of execution plan. This feature automatically improves execution plans that are inefficient due to estimation errors. It extracts raw estimation errors during the query executions. For repeated queries, it corrects the errors, ensuring the selection of more efficient plans. Here is a diagram illustrating how it works. You can see the feedback group has been added to improve the execution plan. This allows planners to use feedback information to fix cost estimates. So the more queries executed, the more accurate the estimated became, allowing ideal execution plans. Now let's take a look at the simple demo of automatic tuning. Using query 31C from join order benchmark, which has multiple joins with non-estimation issues, I will apply automatic tuning to this query until the estimation error is removed. Auto-plan tuning will be completed in about 30 seconds for this demo. The screen capture shows the query being repeatedly executed and plans being adjusted. This continues until no join estimation errors remain. The results of this demonstration are summarized in the next slide. Thanks to the automatic tuning, we achieve a performance improvement of 8.2 times. If your query have many joins, you might consider trying out these features. It could potentially reduce the query execution time. As shown in the result on the previous slide, this feature has the benefit of reducing query execution time. Please refer to the documentation on GitHub for some limitations. Now let's move on to the next slide. next feature. The third feature is the automatic generation of hint clause. This function enables the generation of hint clause necessary for reproducing execution plan. It's especially helpful when you want to use hints but don't know how to write them, or when the plan are too long to write hints easily. For example, if you want to tune using hints, the feature gives you hints as a starting point for your tuning. Many cloud vendors have recently adapted PG hint plan. So trying this feature would be helpful if you need an example of writing hint clauses. In the next slide, I will show you a demo of the feature. Passing the plan ID to the get hint function outputs the hint clauses based on plan ID. Adding those hint clauses to your query lets you reproduce the plan. Next, I will explain the fourth feature, which is the suggestion of extended stats. This is a new functionality. While I will skip a detailed explanation of extended stats here, it is important to note that using extended stats can improve the accuracy of row estimated during planning. But figuring out which columns need extended stats by analyzing plan can be challenging. The great thing about this feature is that it suggests which extended stats to create. The usage is straightforward. Execute the getExtStat function by providing a query ID as an argument. Doing so will yield the syntax for creating extended stats as shown in the example below. DBA can then consider whether to create these extended stats and take appropriate actions. Since this is a new feature, some of you might be curious about how it works. I'll explain it a little. Firstly, to collect information on the table and the columns used in the where and join clauses of a query, it utilizes PGConf stats. Therefore, installing PGConf stats is necessary to use this feature. I'd like to thank Julian for his consent when I discussed integrating PGPlan Advisor with PGConf stats. Thank you. How to get syntaxes for extended stats? The function getExtStat sends a query to PGConf stats to generate the extended stats syntax. There are a few limitations currently. Columns in grouping query and expressions are not considered. And it utilizes compute query ID. So it's only available from Postgres 14 or above. Now let's take a look at demo. First, I will run a simple query that demonstrates the correlation between columns and the resulting estimation errors. Please look at scan rows error. You can see an error of 99 rows in the estimated number of rows. Next, I use a function designed to suggest extended stats to obtain the syntax needed. I do this by providing the query ID as an argument. Then I create the extended stats using the syntax. With the dx command, I can confirm that the extended stats existed. Finally, I rerun the test query to check the effects. Like before, if you look at scan rows error, you'll see that the estimation error has been reduced to 0. This demo used a simple query, but the feature is really helpful for complex queries. Next, I'll cover the implementation and roadmap for PGPlan Advisor. The implementation utilizes 7 hooks listed here. Key among them are executor end hook and explain one query hook. The first one is used to collect information within the execution plan. The offer is used to append the other is used to append the collected information to the result of the explain command. In terms of cooperating extensions, it works with PG hint plan, PG start plans, and PG call stats. Finally, I'll cover the future roadmaps for PGPlan Advisor. Here are some areas I'm looking at for future development. In terms of enhancing the feature to display execution plan characteristics, I plan to add information on the grouping columns. Regarding the advancement of the extended stats suggestion, currently, if there are extendable stats available in query, all are suggested. I'm going to add logic to decide if suggestions should be made. Finally, for integration into operational monitoring tools, I'm considering integration with monitoring tool to make PGPlan easier to use. I'd be glad to have anyone interested join the development. Next, I'd like to provide feedback on the development of PostgreSQL. Its purpose is the advancement of Postgres. Yeah. By the way, do you know the mountain in the photo? Yeah, it's Japan's famous mountain, Fuji. Mount Fuji. Don't you think the shape is beautiful? Yeah. So feedback to Postgres development. In my opinion, there's still room to improve the extended stats. The first point is expansion of applicability. Currently, extended stats allows only for scans and group by, but it should be extended to include joins as well. As demonstrated by the auto-tuning examples from PGPlan Advisor, resolving estimation errors related to joins can improve query performance. So development in this area makes sense. For the second point, improvement of usability. I believe it is essential to establish mechanisms to monitor the usage of extended stats. This is because it is difficult to know whether extended stats were used or not by planner. So two approaches are being considered. The first one is understand usage status on a query-by-query basis. I'm working on improvements to the explain command to show applied extended stats based on Thomas Bondler's POC patch. The other is to understand usage status of the entire database. I will be proposing to provide something similar to PGStat user indices for extended stats. This idea was inspired during a conversation with Alvaro. a commit to force them last year. Thank you. Both are targeting release in Postgres 18. These enhancements would be beneficial for all users, and I would appreciate the cooperation in their development. Next, I will conclude this presentation. Yeah. So in this talk, I covered 3 main topics. First, overview of advisory features. I gave an overview of advisory features, including their classifications, use cases, and effects. Second, PG Plan Advisor. I explained its functions, benefits, mechanisms, and roadmap. Finally, feedback for PostgreSQL development. I proposed expanding the application range and improving the usability of extended stats aimed at advancing the development of PostgreSQL. In conclusion, I hope this talk has sparked an interest in advisory feature, and that it will further stimulate the development of Postgres and its extensions. Let's move to QA session. I will review questions from Google Forms. Oh.
Well, how is the support for like FDWs?
FDW?
Yeah. So like the hint and the generation of that hints and like adapting the rows like the query estimations. Like if I'm using Postgres FDW, that can have like really bad estimations. So it seems like it would be really useful there, but it wasn't clear whether or not that was applicable here.
Your question is, does this tool use for FDWs?
Yeah.
Sorry, I have not tried to test, so I'm not sure it works very well or not. But I think it works fine, because I wrote I consider some FDW, some plan nodes of FDW. So please test it. Go ahead.
I noticed on the GitHub page that it shows that the advisor is intended to be used, not used in production at this point. Is that just because of performance at this point, or it's just not ready at this point? Like, what's your thoughts on that?
So your question is, my tool is not for production ready. So you'd like to know when will you production ready?
Is it just intended to be used in a test environment, or is that just the status of the extension right now?
Yeah. The reason why just for a verification environment, so there is an overhead to plan search or to adjust the cost estimation. So it's better to use verification environment.
Okay.
So and also you can use hint clause to export the plan to production.
Okay.
Yeah, export and import.
Okay.
So thank you.
Thank you for your development. Thank you for your development.
Oh, thank you. I'm glad to hear that. Hi, go ahead. Please go ahead.
When is the first official release of the advisor?
Official release. Yeah, this tool starts as a POC, and some company uses in production, but I mean it's uses in verification environment. So it's okay to use as own risk, at your own risk. Yeah. But if you face some trouble, some problem, please let me know. I'll tackle them. I'll tackle to fix them. Okay. I hope I answered these questions adequately. If you have any suggestions or further questions, feel free to approach me. Thank you for listening to my talk. Thank you.